Okay, Assalamualaikum and hi everyone. So let's continue on the next part of chapter 4, which is on how to calculate the density, or actually we wanted to calculate the volume. Okay, so volume, why volume is important? Okay, because okay, if you look at the landfill area, okay, the cost currently is expensive for land, so we need to estimate the volume of, okay, how much is the volume for, especially on the bulky waste that need to be allocated for this kind of waste. So how are we going to calculate or estimate the volume so we can use the data from the density? All right, so because you know that density is actually rho is equals to density is mass over volume, right? So when you get the density of your waste and from the typical data that you will see in your textbook, which I will explain later in this slide, okay, and with the mass that you know the value, so you can calculate your volume, okay. So if in this diagram you can see those, space consume materials such as boxes, plastic bottles. So in this figure you can see boxes is being compact, okay, into a smaller volume so that more waste can be put into the same location. All right. Okay, so this is the typical density data for solid waste. Okay, so this one you may refer to your textbook table 10.5. Okay, so you see these are the same component as what we discussed earlier. Okay, so the typical density is in this column. Okay, right. So let's go and have a look on example 10.2. Okay, so 10.2 is actually wanted you to, okay, to calculate, to estimate the density of a solid waste sample. Okay, so as the previous example that I've shown to you, so our basis is 100 kilogram of waste, right? So these are the same value for the percentage of mass given in the previous example, right? So you need to fill up these two column. Okay, so typical density, again, you can calculate, you can have the value from this table 10.5, right? So by for example, for food, so it's 290, so 290, so you fill up here, right? So then you can calculate, okay, and then you get the mass earlier. Okay, initially you have, okay, suppose you have this earlier column where you calculate the dry mass, right? Okay, so you can use this mass, okay, in order to calculate the volume. Alright, so sorry, so if you look at example, okay, so when you have already the typical density and then the dry mass that you have calculated earlier, so by using this value rho equals to m over v, so you can calculate your volume. So this is the value here. Alright, so I think it's a very basic calculation that you can solve by your own, right? And then you can total up, okay, total up the volume here, okay, how much volume is needed, or otherwise you calculate all the density, okay, sorry, you calculate all the volume and also all the mass here, okay. So the actual density is actually m over the total mass over v, so you need to calculate the total mass here. Okay, all right. So next, we are going to explain on the chemical composition. So why is it important to know the chemical composition of your waste? Is to evaluate alternative process for energy recovery, or how you can transform your waste into other material. But for this chapter, we are actually wanted to know the chemical composition of your waste for the energy recovery. Alright, so you can see here later in this chapter in the subtopic after this is to calculate the energy content. Okay, so how are you going to do this? You need to know the chemical composition first of the waste that being produced, right? So these are the method that used is proximate analysis, knowing the moisture, volatile matter, ash, and fixed carbon. Okay, so these are some example, and then you will calculate the carbon, hydrogen, what we call CHONS is carbon, hydrogen, oxygen, nitrogen, and sulfur, and also ash. Okay, so this will be discussed in the next topic, right? So okay, this is from the MSW, right? So how to calculate the energy content? All right. So this one, okay, if you refer to your textbook, this will be in page, starting from page 582 until 585 in your textbook. Okay, so you have dry basis and also ash free dry basis. So this one is actually for energy content. Okay, so this is equation 10.2. Okay, in your textbook, this one is equation 10.3. Okay, right. So you will find the energy content as discarded, okay, times this 100% and over 100 minus the moisture. So you need to, that's why we need to calculate the moisture in the first part of the calculation. Okay, so then only you will continue to calculate maybe the density, the volume, and then the energy content, right? So the second equation, which is 10.3, is by taking into consideration of percentage of moist and also ash. Okay, the 10.2 is only moisture. All right, so we proceed to the example, which is example 10.3, estimating the energy content of a solid waste. Okay, so if you look at here, it will be the same, the same value as the example 10.1. So it is like a continuous. Okay, so first you determine the moisture content, then only you can calculate the other thing, such as the volume, energy. So later on you will see you can calculate the other elemental composition. Okay, so the table will be a dynamic, right? Okay, so the question asks you, okay, this is 100 kilogram, and then what is the content of dry basis? Okay, what is the energy content of dry basis? Okay, and then ash free dry basis. Okay, assume it is ash is 5%. Okay, so you need to consider that, right? So what should you do? The first thing, you refer to table 10.7 to know what is the energy, the typical energy for every component. So for instance, food waste is 4650. Then you develop a table like this. Okay, this one is actually the percent mass, and this one is the energy that you get the figure from this table. You see, 4650, and then paper is 16,750. You see, so you extract the data from here based on the component, right? So the total energy is actually the mass percentage times 4650. So you get this data, right? So you times up all this value, and then you sum up, you will get this is the total energy. So this is total energy content of your waste, right? And then the question just now wanted you to do first with dry basis. So you see here, dry basis and also ash-free dry basis. So if you look into the equation, so this is dry basis, you have to subtract moisture percentage. This one you need to subtract the ash and also moisture percentage for ash-free dry basis, right? So this is not the final answer. So you need to do like this, okay? And then when you, okay, total energy is total times total mass. So what you can do just now is by having okay, similar, this is actually 469. It should be the same. The earlier table is 4650, right? So this one should be 4650 as well, right? So this one I've already explained to you. So this one is the energy content. Okay, this is per 100 kilogram. So this is the per 100 kilogram. This is not yet the dry basis. Okay, so for the dry basis, if you see that, you need to subtract 21%, the one that you already from my second video calculating the moisture percentage. Okay, so you will get this value. So this is the dry basis. So the next one is ash free dry basis. So you need to subtract percentage ash and also percentage moisture. So percentage ash given just now is 5%, right? So moisture just now is 21%. So you add up, you put into the equation and you finally will get this value. Okay? So I think for this I stop here. For the chemical content, I will continue in the next video. So see you on part 4 for the chemical content. Thank you.